While the planets often steal the spotlight in classrooms and space missions, there are smaller worlds in our solar system that deserve just as much attention. 4 of the most fascinating of these are Jupiter's largest moons, known as the Galilean moons. Even though they orbit the same planet, they are strikingly different. One is the most volcanically active world we know, another may hide an ocean where alien life could exist. A third is not only the largest moon in the solar system, but also carries mysteries buried beneath its surface. And the last is an ancient, scarred world like a time capsule of the solar system's earliest days. Today, let's journey through each of these moons, Io, Europa, Ganymede, and Callisto, to uncover what makes them unique and why NASA and ESA are dedicating missions to them this decade. By the end, you'll see why these moons could reshape how we understand our place in the cosmos. We begin with the innermost of the 4 Io. At first glance, it might look similar in size to our moon, but Io is unlike anything else we've seen, orbiting only 350,000 kilometers above Jupiter's cloud tops. Io feels the giant planet's gravity in extreme ways. Imagine tides not of water, but of rock. Tidal forces stretch and squeeze Io by up to 100 meters. For comparison, Earth's ocean tides usually rise and fall by only a couple of meters. This constant flexing turns Io's interior into a furnace. Io is made mostly of silicate rock and iron, more like a planet than a typical icy moon. Strangely, it contains almost no water, less than any known object in the solar system. Its dense rocky interior drives one of the most remarkable features ever discovered: hundreds of active volcanoes. When Voyager 1 flew past in 1979, it captured plumes of volcanic material erupting hundreds of kilometers into space. These were the first active volcanoes ever seen beyond Earth. Some of Io's lava lakes, like the enormous Loki Patera, glow so brightly they can saturate spacecraft cameras. Others, such as Tvashtar, produce fiery fountains that rise far above the surface. Io's surface is a spectacular mix of colours, yellows, reds and whites, all caused by sulfur compounds deposited by eruptions. Some mountains tower higher than Everest, standing alone on the plains like gigantic stone monuments. But Io's uniqueness doesn't stop at geology. Its eruptions feed material into Jupiter's vast magnetic field. Particles escaping from Io create a giant neutral cloud and a torus of plasma encircling Jupiter. These interactions generate aurorae, not only on Jupiter itself, but also glowing above Io's surface. If you stood on Io, Jupiter would loom 39 times larger than our moon appears in Earth's sky. You would see towering plumes on the horizon, sulfur snow across the plains, and in the distance, the giant planet storms flashing with lightning. Io is a place of both beauty and violence, an alien world sculpted by fire. Next, let's turn to Europa, perhaps the most intriguing of all. Slightly smaller than our moon, Europa looks smooth, bright and icy. Its surface reflects sunlight so well that it shines 5 times brighter than the moon in Earth's night sky. But what lies beneath this ice makes Europa extraordinary. Crisscrossing the surface are dark lines, lineae, that stretch for thousands of kilometers. These cracks likely form as Jupiter's tidal forces pull Europa apart, allowing warmer material from below to seep upward and freeze. Strange chaos terrains show areas where the crust has broken apart and refrozen into jumbled blocks of ice. Beneath that crust lies a global ocean of liquid water. Evidence comes from changes in Europa's magnetic field and the way its crust rotates slightly over time, suggesting it floats on something fluid. This ocean may be 60 to 150 kilometers deep, containing more water than all of Earth's oceans combined. And crucially, scientists believe it is in contact with the rocky seafloor. That means minerals and heat from below could mix with the ocean water, exactly the kind of environment where life thrives around hydrothermal vents on Earth. Radiation from Jupiter constantly bombards Europa's surface, breaking water molecules into hydrogen and oxygen. The hydrogen escapes, but the oxygen remains, forming a thin atmosphere. Even more exciting telescopes like Hubble have spotted plumes of water erupting hundreds of kilometres above Europa's south pole. If confirmed, these plumes could allow a spacecraft to sample the ocean indirectly, no drilling required. Imagine standing on Europa's frozen surface, the airless silence, the faint glow of Jupiter above and beneath your feet, an ocean world with the potential for alien life. It's no wonder Europa is one of the main targets of upcoming missions. NASA's Europa Clipper will perform dozens of flybys in the 2030s, while ESA's JUICE mission will study Europa alongside its neighbours. For now, Europa remains one of the strongest candidates for life beyond Earth. It holds the water, the chemistry and the energy, all the essential ingredients. The only missing piece is discovery. Our journey continues with Ganymede, the largest moon in the solar system. With a diameter of over 5,200 kilometres, it is even larger than Mercury. If Ganymede orbited the Sun on its own, it might well be considered a planet. Beneath its icy crust lies a vast ocean, even deeper than Europa's. Ganymede could hold more water than any other body in the solar system, but its true mystery lies elsewhere. Ganymede is the only moon known to generate its own magnetic field. This was discovered by the Galileo spacecraft in the 1990s. Magnetic fields usually require a hot, convecting metallic core like Earth's. Yet Ganymede should be too small and too old for its core to remain molten. So how does it produce a magnetic field? One theory suggests tidal heating plays a role. Ganymede is locked in a gravitational resonance with Io and Europa. This constant tug of war stretches and warms the moon's interior, perhaps enough to keep part of its core liquid. Another explanation involves its salty subsurface ocean, which might conduct electricity and amplify magnetic effects. On the surface, Ganymede is split between dark ancient regions covered in craters and lighter areas carved by ridges and grooves stretching for thousands of kilometres. Viewed from space, these patterns tell a story of geological upheaval. But standing on Ganymede would be equally impressive. The sky would be dominated by Jupiter, and above the thin oxygen atmosphere, aurorae ripple and shift, evidence of its mysterious magnetism. Though radiation still makes the environment dangerous, Ganymede offers a rare combination: size, water and magnetism. It's a world that refuses to fit neatly into our expectations. Finally, let's visit Callisto, the outermost of the Galilean moons. At nearly the size of Mercury, Callisto is the third largest moon in the solar system. But unlike its siblings, Callisto seems frozen in time. Its surface is one of the oldest in the solar system, scarred by billions of years of impacts. Craters overlap craters until the surface is saturated with scars. Gigantic structures like the Valhalla Basin, spanning 3,800 kilometres, dominate its face, with rings rippling outward for thousands of kilometres. Unlike Io or Europa, Callisto shows no signs of geological activity. No volcanoes, no tectonics, no resurfacing. It is a fossilised record of the early solar system preserved for over 4 billion years. Yet Callisto has its own value. Beneath its crust, data suggests there could be a subsurface ocean. And because it orbits far from Jupiter's radiation belts, Callisto would be a safer place for future explorers to establish a base. With abundant water ice for life support and fuel, and a stable environment for construction, Callisto could one day serve as humanity's outpost in the outer solar system. What might it feel like to stand there, a quiet, desolate world, under Jupiter's distant glow, where the past of the solar system lies written in ice and stone? Callisto may not be lively, but it may one day help us take the next step outward. Together, these four moons, Io, Europa, Ganymede and Callisto, form a miniature solar system of their own. They show us extremes of geology, hidden oceans, magnetic mysteries, and ancient relics. And soon, with missions like Europa Clipper and JUICE, we will get answers to questions that have lingered for centuries. Does Europa truly hide life beneath its ice? Why does Ganymede possess a magnetic field? Could Callisto become our future outpost? The Galilean moons remind us that exploration doesn't always mean leaving the solar system. Sometimes the most extraordinary worlds are orbiting just a giant planet away. So, as we continue to look up at Jupiter in the night sky, let's remember its moons hold secrets that could reshape our understanding of life planets and the universe itself.